Achim Schneider from Parity Technologies, and let me start by sharing my screen. So I hope everyone can see my screen now, and I will start with my presentation and introducing myself again. Achim Schneider, I'm a smart contract tooling developer at Parity. I'm experienced in programming with front-end tooling like TypeScript, React, and also Rust. You can reach me, you can find me on GitHub or on Element. Okay, I want to talk today about two things Parity Technologies usually works with and how we combine them. So usually with Parity, if you build on Parity with Substrate, you build in Rust, and usually you use WebAssembly. You usually compile your Rust to WebAssembly to execute it. And like if you're not completely new to the ecosystem, you have probably heard about Substrate palettes. So Substrate is a modular framework to build blockchains, and you can compose different palettes, different building blocks to build your own Substrate-based blockchain in Rust. And so you have a big variety of pre-built palettes which Parity technology provides, from which you can build your own blockchain. So there are like elections, identity, asset staking. You can also easily build your very own different palettes, different building palettes, and build your own. One particular palette that I want to talk today about is the smart contracts palette, which allows you to write smart contracts in Ink. So I will talk a little bit about the smart contracts palette first, and then I will go over and give an introduction to Ink. Okay. Yeah, so the way that we treat our smart contracts in the palette contracts is that we use Ink to program smart contracts in Rust. So Ink is an embedded domain-specific language, and we will see soon what precisely this means. And then we compile those smart contracts which are programmed in Ink to WebAssembly. We obtain such a WASM blob. And then we execute this WebAssembly blob in the palette contracts. And so what I should mention here, like palette contracts is a WebAssembly runtime for smart contracts. And we can use Ink to write smart contracts and compile them to WASM. But there are also other languages which you can use to program smart contracts and then compile them to WASM. So there is ask, which is some assembly script EDSL, which was already built for this purpose. And then actually, indeed, you can also compile Solidity to WebAssembly. There exists a Solang compiler which allows you to do this. And I mean, if you are like curious about this and you want to dive further, you would even be able to build your own compiler, your own design your own to WebAssembly. All you have to take care about is that finally the compiled WebAssembly code calls like the right APIs from palette contract for the smart contract execution. Okay, so the palette contracts is a quite useful WebAssembly runtime, and there is a variety of languages that you can use to write the smart contracts and to execute them in palette contracts. So then you might ask, like, okay, you're building in the Polkadot ecosystem, and you're proficient with Rust, or you want to learn Rust and to do this, and then there is this thing like in the end, palette contracts is just one of many palettes which you can implement in the substrate-based blockchain. And then yeah, you could ask, okay, so finally what you do with those smart contracts is you implement some business logic, right? So what the heck, like you could also build just your own palette which serves the same purpose, implements the same business logic as a smart contract. And then the question is, if you want to, if you have some business use case which you want to implement on Polkadot, should you implement this as your own palette or as a smart contract? Well, there is this thing that a smart contract is definitely like there's way less effort involved to just deploy a smart contract than to obviously deploy your own substrate-based chain, like as a parachain on Kusama or Polkadot, or also as a standalone chain. So yeah, smart contract development is just way more approachable than starting right away with your own parachain. Yeah, so this is definitely like one big advantage. You can just start building your own smart contract, and you can deploy it on an existing parachain. Currently in production, there is Aster, and like there Aster, they have a parachain on Kusama, Scheiden, where you can already deploy Ink smart contracts, and very soon this should also be possible on Polkadot. There are like more chains to come soon, probably. Yeah, like there's way much less of so it's just the easiest way to get started building something, probably with Rust on Polkadot. What you should be aware of if you build smart contracts, this is untrusted code. So this means that there's like it's easy to develop, but there are things involved like gas metering. So which means, yeah, if you have your own palette, you have a lot more like technical freedom to implement whatever you want and to charge the fees that ever you want to take for it. And if you have a smart contract palette, you don't want anyone to deploy anything which brings down the chain by some kind of brute force attack, like very heavy payload. So you have to implement the gas metering since it's untrusted code. So you have less technical freedom, but it's way easier to just develop something there. And then indeed, yeah, you can just treat those smart contracts as first-class citizens, and then yeah, like you can think about just building your complete business logic as an Ink smart contract and deploy it on an existing parachain. But then if you want to use the palette contract, the WebAssembly runtime, as part of your own chain, there are different ways how you can implement palette contracts in your own substrate-based blockchain. So you can treat your smart contracts as first-class citizens. So you can just go for some smart contract chain which main purpose is like deploying smart contracts there. Like there is like Aster, which allows you to just deploy WebAssembly smart contracts, and then you should have some unique selling points. Like in the case of Aster, they have like this DApp staking, but they also actually have an EVM palette. So they also support Solidity smart contracts, like EVM Solidity smart contracts, as well as Ink or WebAssembly smart contracts. And they also provide some interfaces, which was just published recently, which allow communications between EVM and WebAssembly smart contracts, which is quite interesting. You can also Okay, you can also treat smart contracts as second-class citizens, meaning that you can think about some parachain with some palette in which you implement some business logic, like a decentralized exchange, and then you want to add some programmability to your users. For your users, you want to allow them to program certain behavior on your blockchains, and you can add palette contracts as an extra building block, which allows you to deploy smart contracts for some specific use cases, like they could trigger some automated trading actions on a decentralized exchange, while the decentralized exchange by itself is implemented as its own palette business logic. And then one last thing that you should be aware of is probably also a good idea that if you want to later on encode your business logic in your own parachain, you can always start with building an Ink smart contract. It's already business logic encoded in Rust. You can then take your Rust-based smart contract later on, use all the already implemented business logic, and convert it into its own parachain. So definitely Ink smart contracts is a good way to get started with Rust blockchain development on Polkadot. Okay, I did talk quite a bit about palette contracts, the WebAssembly runtime for Substrate. Now I want to focus more on Ink. So Ink is actually, it's a Rust-based language to develop smart contract. And what does this mean precisely? Well, if you know Rust, you will realize that this is actually totally valid Rust code. This is a module, my contract, which does contain a struct which carries which declares one value, one Boolean variable, and it implements actually some functions to like a constructor function, a get, and a flip function, which allow to read the struct's value and to mutate it, to flip it from true to false and vice versa. So this is totally valid Rust code, and if you just copy and paste this into your favorite IDE and try to use cargo build to compile it, it will compile and build. And the approach that we took for Ink smart contracts is actually that we provide some custom macros, like you can think about it as some kind of decorators, which you have to add to your code and which will instruct the cargo contract compiler to add certain properties which are required to actually call the APIs from the palette contracts WebAssembly runtime. So what you see here are those decorators which I mentioned. So there is one macro which like decorator or macro which lets our compiler know that this is actually an Ink contract at the beginning, and then like there are other macros which are instructing our compiler that at certain points we declare actually the storage of the smart contract, and for every Ink smart contract there's precisely one storage object, which is like the state of the storage. And then we have a constructor, and something specific for Ink is that actually we can declare more than one constructor. Here in this case we declare as one, the new constructor. And then we have two messages, and the Ink message then just tells the compiler that those are like extrinsics, like callable function of the smart contract, which are exposed through the smart contracts API. They can be then later on called by some dapp, and we will later see how this works and can be done. Okay, there right now two ways where you can start right away without investing any money to experiment with being smart contracts. There is a Substrate contracts node. So the smart Substrate contracts node starts a development chain on your local machine. So it executes some local Substrate chain which implements Pellet contracts, and you can, by executing it, deploy your smart contracts on your local machine. And then another way to experiment with smart contracts is the Rococo testnet, where you can deploy Ing smart contracts. Right now, there's also, since a few weeks, there's also like Aster's Kusama test, Aster's Kusama net in production available, where you can deploy Ing smart contracts in production. Okay, there is a repo which we created recently where you can keep track about projects building with Ing and implementing Ing, and also Ing tooling and first examples of Ing apps. So there are quite a few other projects coming up, like Fala Network, which is doing some decentralized cloud computation. So they actually are running smart contracts off-chain in some trusted execution environments. There are Peak, which are like some IoT blockchain solutions for machine communication. There's Aleph Zero, which actually is not Polkadot or Kusama parachain, but is a standalone chain which replaces the consensus mechanism. So actually, it's a decentralized. It's a DApp, not a blockchain, but they still implement Pellet contracts and WebAssembly smart contracts and Ing. Okay, and soon probably much more to come. At this point, I would like to go over and to invite everyone to actually try out Ing-based smart contracts and hack with them. So because what I would like to do here is I created a small GitHub repo which you can access through tinyurl.com/ibc-hack, and I would like to invite everyone to just open it and follow the few basic instructions which are outlined there. This way you will be able to start your own blockchain node on your local machine, which allows you to deploy smart contracts, and then I want to edit some smart contracts together with you. Okay. So just tinyurl.com/ibc-hack. Should open this GitHub repo for you. And then please be aware that there are two different instructions for either Linux or macOS. It's just 4 command line, terminal commands which you have to execute to get your own node, local node running, which allows you to actually deploy and interact with your own Rust-based smart contracts. So it's really just, I'm on Linux, so I will follow the 4 steps from the first instructions. I leave it to you to either on Linux or macOS execute those 4 instructions until you have your own local contracts node running. if something goes too fast now, I also invite you to follow those steps later on and to at least try out the very basic example of an Ink smart contract. So the first instruction just downloads the contracts node. The second one unpacks it. The third one just CDs into the correct directory. And number 4 then finally gets your node running, and then you will see that it just starts producing blocks. Yeah, if you get this output, your local node runs. And we are good to go, and we are already ready to deploy our smart contract on our local computer. I'll just wait another 1 or 2 minutes to give everyone's opportunity to open the repo and to type those 4 commands into their command line. All right. Then we continue here with instructions. Actually, there is a link here to the Ink Playground. I would recommend to open this in a new tab, so that you keep your browser tab with its repo and instructions open. And what this actually does, the first instruction just loads a browser-based IDE, which allows you to edit, compile, test, download, and share your Rust-based smart contracts, your Ink smart contracts. So let's get the screen as large as necessary to be able to make you see what I do here. So if we open the Ink Playground, what we can see is actually it loads with some standard smart contract, which is like the one which I more or less already showed before in the introduction. This is a flipper contract, which is a contract which carries just this one Boolean variable. Then it comes with those few extrinsics. Like there are actually, in this case, I mentioned in the introduction briefly that you can have constructor overloading. You can define different constructors, and this is something which you cannot do in Solidity. And actually, you see that this smart contract ships with 2 constructors, a default constructor and also like an individual constructor. And the difference is that the default constructor just initializes, like it instantiates the smart contract with the default value, which is false, and alternatively, you can instantiate your smart contract with either true or false explicitly. So this smart contract just carries this one Boolean variable, which can either be true or false, and then it exposes this one message, this extrinsic, which allows you to flip your state from true to false and vice versa, and also this one extrinsic, which allows you to read the smart contract storage. Okay, but we also have here what Ink also provides is built-in unit test. So we can here define some basic tests, and you see like in the test sections that we actually instantiate a flipper contract, and since we instantiate it with its default value, the default value should be false. We check that this smart contract actually has the state variable's value as false. And then there's one slightly more complex test which allows you to instantiates the smart contract, and then we check that initially the smart contract carries false, and then after we flip the variable, we indeed get true. So yeah, we can open the Ink playground and we can go straight ahead and start hacking on the smart contract. Before we modify anything, we can just see that actually the tests run. Yep. Test results, okay, 2 passed. And then we can also compile and download the smart contract. Compiling the smart contract takes a few seconds, but not too long. Yep, okay, that's it. Smart contract is compiled, and then we can download it. And what we can do next. So at this point, I would like to invite every participant to click on compile and then on download. Okay, and I will go now on and I will deploy the smart contract, and I want to invite you all to do actually the same thing. So what I do is I click on deploy on contracts UI. On the top right, there is a button in Ink Playground, which opens actually in a new tab, the contracts UI, and contracts UI is a front-end tool which allows you to interact with smart contracts which are either deployed on Scheiden, Shibuya, on Rococo, like on the Astra Kusama network, or like our test networks, or actually on your local node. And I would like to invite you to, in the top left on contracts UI, to select local node. And then if you follow the steps, there's those 4 command line commands before, and you got your local node running, then this should connect, and you should be able to actually deploy your smart contracts through contracts UI on your local node. Okay. I go on add new contract and upload new contract code. And then there is this section upload contract bundle. Like we have to select an account on which we want to, with which we want to deploy our smart contract. And then if you start the local contracts node, it ships with some like it provides some test accounts which are already there, and we can just leave the first account Alice selected. That's totally fine. And then I select the smart contract that I downloaded before on the Ink Playground and upload it. So I go to upload contract bundle, I select this downloaded smart contract as my contract bundle which I want to upload, and I change the contract name to Flipper because this is a Flipper contract. Okay, so we are good to go. I go on next, and here on after clicking next, this is the second instantiation page of the smart contract. If you go back to the smart contract, I want to remind you that this smart contract actually implements two different constructors. One which allows us to declare explicitly the initial variable of our smart contract state, and one is the default constructor. So we have here in our code two different constructors defined. And if you go to Contracts UI, we see that we can choose from two different constructors. One constructor is actually the default constructor, and then you didn't face this problem. Like I had probably like two different smart contracts already in my download folder. So just select the smart contract bundle that you downloaded from Ink Playground and upload it. And then you have those two deployment constructors. One constructor is called new, and it receives some initial value, which is a boolean, which is either true or false, and the other one is the default constructor. So we can select the new constructor, and then we can tell Contracts UI to instantiate this smart contract with the explicit state variable true. And we go to next and upload and instantiate. Okay, cool. That's it. We uploaded and instantiated this smart contract already on our local contracts node. So on our local palette contracts runtime, which we execute on our local computer. And then you will see like it just after instantiation, Contracts UI switches to the interact mode. And here in the interact mode, you see that the smart contract actually exposes two different extrinsics, two different functions which you can call. One function is flip, the other function is get. And so this reflects those two messages here, like all the extrinsics or the callable functions of a smart contract which we want to expose and which we want to interact with in our D app are actually annotated with a message macro in the Ink message macro. And yeah, indeed, there are those two functions. There's this one function which allows us to mutate the smart contract storage, and since this is actually mutating the storage, it obtains like a mutable reference to self, so it's allowed to actually mutate the storage. And there's another function which has a non-mutable reference to self, which just reads like it accesses like the struct, and it just reads its value and returns it. So we did instantiate the smart contract with true. So if we just the smart contract state variable should actually be true right now, and we can just call the get function and see the outcome. And indeed, calling get gives true. On the right side here, you see the core results. We can easily execute this a second time. It will still give true. And then next time we can call flip, and flip will convert the smart contract storage. It just takes the smart contract storage value, the Boolean, and inverts it. It switches true to false and false to true, and updates the smart contract storage accordingly. So we can just call this. It says call success. And now let's call get a third time. Before we always got true, and now after mutating the storage and actually calling flip, we expect to get false. And yeah, that's true. Okay, that's a very basic way how you can edit, compile, and execute smart contracts. So there are different ways to go from there. If you follow the tutorials, you should probably at one point, Ink Playground is very good to get started with smart contracts. It's also very good to share code snippets, to discuss them in forums, because it has this built-in sharing functionality. Whenever I edit a smart contract, I can just create a GitHub gist with one click, and I can either share the link to this GitHub gist, or I can share the link to the playground, which contains the edited code. So it's a very useful tool to just hack on something, try something out, get started with smart contracts. Obviously for workshops, and also to discuss problems in forums. But if you want to proceed with Ink Smart Contracts, I would recommend you to also install Cargo Contract and all the machinery and toolchains. It might take you half an hour, and then you are ready to edit them on your local computer in your favorite IDE like NeoVim, Visual Studio Code, or Emacs, or whatever you use, and to compile them locally there. Okay. Yeah, at this point, we did already compile and build and test our first smart contract. And since there are 10 minutes left, I have some task. You can maybe yeah, you can try and think about it a few minutes for yourself, and then I will just go through it and show you how to do it. So I thought about a basic first exercise, which you could try to hack on a smart contract to modify something in a non-trivial way. So just in the case that you closed the repo that I shared before, please reopen it. tinyurl.com/ibc-hack. And yeah, there's this exercise too. I would just like to invite you to go open Ink Playground. It will open with the standard Flipper smart contract, and to modify it in a way. So Flipper is the most basic example of a smart contract, as easy as a non-trivial example can get. It carries one Boolean variable, which can be true or false, and which can be switched. And I would just like to invite you to change the Boolean variable to an integer like I8. And to make the smart contract work in a way that this smart contract then carries a state variable, which is just an integer variable. And then obviously we want not to flip an integer, we want to set an integer. So we change the extrinsic from flip to set. And if we want to set it, we want to set it to a specific value. So it will receive an input argument. And then I would like to invite you to modify it in a way such that you can have a smart contract where you can actually set an integer variable and update it and read it. So that's a very basic exercise. I would like to invite you to try out for a few minutes, and then I will do it together with you. Just to give you an idea about where in a smart contract like variables are stored and how to access them. And then as a first point, maybe try to make the smart contract compile. It will compile even though the tests are malicious or like are not adopted. And then yeah, if you want to continue practicing a bit further, probably also after this workshop, I can yeah, you're also very welcome to modify the tests or to define some new meaningful tests regarding to a smart contract which keeps an integer variable in storage.
So, until then, we do have a few questions in our comments. During the workshop, we did see some queries come in the comments. So, if you take a look in the comment section.
Okay. Let me check.
Yeah, we did have a few queries coming in, so.
Okay. Yeah.
All right, so I'll just.
I mean, that's a great idea. Like, I can I take care of the questions, and anyone who's interested in the questions can pay attendance, and everyone else can try to hack on this small exercise and to replace a boolean with an integer, and then I go back and do this by myself. Hi Achim, this is Praveen. What are the dependencies that need to be taken care of? So yeah, for developing an Ink smart contract, that's a good question. There are the basic like Ink dependencies, and I would recommend you if you go to Parity Tech, GitHub Parity Tech Ink repo. Okay, actually. Yeah, actually, for Ink smart contracts are Rust smart contracts. So basically, it's Rust, and the dependencies are handled in cargo.toml, and there usually you need to declare those dependencies like Ink primitives, metadata, Ink env, storage length, and scale info. So scale is for converting the Rust types into like serialize them and make them accessible to our like front-end apps and vice versa. And those Ink underscore dependencies are the dependencies which are always required when writing Ink smart contracts. So you usually need to add them to your cargo.toml file. But actually, if you install cargo contracts locally, the cargo contract compiler, and you just type cargo contract new flipper, or however you want to name your cargo, your Ink smart contract, then it will create a new like smart contract template which already has a cargo.toml with the required dependencies. And can we not indicate at one line in the beginning that this is an Ink smart contract instead of writing this line in so many places? Okay. So the thing is, we don't write precisely the same line so many places. So we actually indeed annotate one time at the beginning that this is an Ink smart contract. And you see like this is Ink : contract. And then we just have a lot of different other macros which indicate that this is the storage of the Ink smart contract, and that this is a constructor, and this again a constructor, and then there are two messages, and it's just every time you declare a message which you should want to expose through the ABI to some DApp, make it callable, you need to annotate this explicitly, because there will also be messages which you don't want to expose in more complex smart contract examples, like internal messages. Yeah, so it's not the same line many times. They're different, and they are required there. Choice between writing a new smart contract using Ink and modifying an existing palette, which one should be preferred? Yeah, like I try to motivate this a little bit in the workshop. This depends a bit on your specific use case. You should be aware, like if you really want to send something to production, if you want to build your own palette, you need to, in the end, you just need to start your own blockchain, which might be easier on Polkadot than just building a smart standalone chain. And the first instruction just downloads a lot of advantages if you do this, like the shared security through the relay chain, for example, and the interoperability and all this. Still, it's a long path. Like you need to probably win different, like a blockchain auction to do this. You have a lot more freedom to build precisely, like optimize for your specific use case if you either modify an existing palette or you build your own palette. But if you write a smart contract, I mean, the smart contract that we opened here together and that we now modify together, no one prevents you from just sending it to production right now. Like you might pay a few cents for A-Star's Kusama net to deploy it there, but the fees won't be high. And then it's there and it's up and running. And then, yeah, it's also like, yeah, palettes will always be more optimized and for like more optimal for specific well-elaborated business cases, but it's just way easier to start with smart contract. Okay. Okay. No worries. Since there is a little bit time left, I would just suggest that I just do the exercise that I motivated before. So we have the smart contract storage, and it's a Boolean. And what I will just do is I will modify it to an integer. And then you will see that like the constructor currently, it receives an initial value, which is a Boolean. We don't necessarily want to have this as a, well, this is an integer. Like the initial value, like since our smart contract now stores an integer, we don't want to instantiate it with a Boolean variable, but with an integer. And we don't want to flip anything any longer, since our smart contracts now carries an integer variable. We want to set this integer variable. And so we are still mutating storage, but we want to pass the set function an argument, which is an integer. And then we want to set the smart contract storage to this value that we passed. And then if we want to read the smart contract storage, we don't want to read a Boolean any longer. It should not return a Boolean, it should return an integer. So that's already it. This is a small exercise. It's still a few more lines of code to make the tests pass, but we are also already ready to to actually compile this modified example. To download it and to deploy the contract CI. Add a new contract, and this time, oops, no, sorry. Upload a new contract bundle, exactly, and there we can add the contract, and I will call this header contract. Okay. We see that indeed now, like our deployment constructor, there's a default constructor, the default value will be 0. But there's now a constructor which receives an integer value as initial value, and we can just give it like the value 10. And we can instantiate this. And now we see like we don't have any longer a flip function. I modified this accordingly to have like to have a set function which receives is no longer like this function now receives an argument. It's an integer variable. So so if we want to like we can easily call the get function, and since we picked the constructor which instantiates this smart contract with an initial value of 10, we would accept that's interesting. I obviously did. That's interesting. Ah. Yeah, this should not be out of bounds, but it somehow is. So there was a small overflow happening. Actually, I changed the integer from I8 to I32 now. Wow. Let's call it Cetera I32. Initial value 10. And we call the getter. Yeah, now this works as expected. Actually, I have to think like why it didn't work with I8. Because 10 should not be out of bounds. But I defined an I32 integer variable, which is certainly big enough, and then I can instantiate this with value 10, and I can call get, and we get the storage value 10, and I can set this and update this to another value, let's say 5. And we can get it again, and actually it mutated the storage value to 5. Interesting. Okay. Yeah, this is like a basic non-trivial modification which you can do by yourself to modify the very basic Flipper smart contract accordingly to get to get something which allows you to set a storage value and to read it. Okay. Let me also update this because I just didn't expect I8 not to work for this, and I definitely think after this workshop why this failed. Let me just modify the description to I32. Okay. Are there any more questions?
Right. So we do have a few questions actually.
Sure.
Right. So there was a question from there are a few questions from our community and our viewers today. So one of the question is, can you elaborate on how smart contracts on Ink overcome the gas fee issue?
I mean, you have a built-in gas metering the same way as you have for Solidity smart contracts. So yeah, you just have to pay gas fees for deploying and executing smart contracts.
Okay. So another question is, but if a choice between writing a new smart contract using Ink and modifying an existing palette, which should be preferred?
Oh yeah, but I already said this. Like it depends on your use case. If you just want to get something running, like there's a very short path to just build something with a smart contract. Like let's say an NFT project, even a DEX, something like Uniswap. Like I shared this awesome Ink repo earlier, and one of the example projects which are built there, like which are linked there, is like actually a decentralized exchange, like more or less the logic which is modeled by Uniswap version 2 as a smart contract. So this is totally possible to build it as a smart contract, model it as a smart contract. However, if you have a very like building stuff as a palette means you have like way more freedom to build something very specific to your needs, and you can have more freedom to choose like what fees you charge and for what you charge fees than with building gas metering.
Okay, so another question is, how is a Rust-based Ink smart contract better than the Ethereum-based palette?
Yeah, I mean there are different reasons why we think it's just more natural, because you write in Rust, and Substrate is like a Rust-based world. And as I already motivated, like if you build something and you start with like you can just deploy a smart contract paying a very low fee, so it's a very short path to building your project as a smart contract. And then later on, if you want to convert to your own parachain, you already have your business logic program with Rust, and it's way easier to later on convert this to your own chain. And then it's just a thing that we think that WebAssembly is an open standard in the future. There is an ongoing discussion about performance of WebAssembly versus EVM, and there are some indications that WebAssembly outperforms EVM, at least in the case of smart contracts, which are like very optimized in size of like in terms of binary size of the compiled smart contracts, and there's like also an ongoing process of further optimizing this. Yeah, it's the thing. It's Rust. It's more native in the Substrate world. It's easier to generalize to a chain. It's an open standard. It's WebAssembly.
Okay, so one of the attendees has a question with. So they know the basics of Python and C++. They have just started in the programming career. So how easy would it be for them to start developing smart contracts, and what is required further more than that to start off?
You mean for someone who knows Python or C++?
Right. What would be the ease of them? Ease for them to start with building smart contracts and whatever we discussed today, like, as a beginner.
Yeah. Like it's well, at least if you know C++, I mean, you need to know some Rust, but there are also a lot of advanced concepts of Rust which you don't have to take too much, like which you don't need to know too well to get started with Ink smart contracts. So it might be like learning Rust is beneficial, and it's a very precise language, and we think it's in some aspects also more secure than Solidity. So I'd say it's worth it. And actually, if someone who is not familiar with Rust wants to start with ink-based smart contracts, I would just probably encourage the person to get started with some very basic Rust tutorials. They are not like most of the very advanced Rust subjects, like parallel processes, lifetimes are not needed to just program Ink smart contracts.
Okay. So we'll take one last question.
Yeah.
So you did mention community testnets before this. So what is the difference between Kusama and the community testnets? Like,
yeah, actually, I guess Kusama is what we call like a canary testnet, and what we mean by this is like it's actually a testnet. It's a bit more than a testnet. It's something providing some real economic value. So like there are like every parachain, and also Polkadot has pure testnets. They have a faucet. You can get like free tokens there to experiment with everything, to deploy your smart contracts there, see if everything works. But we just realized that a proper test net, which allows you to test under realistic conditions, should also provide some economic value. So Kusama is somewhere in between. Kusama actually has some economic value. It's just the network on which is more bleeding edge. Every new feature gets deployed there. Fees are a little bit lower there, and especially deploying a parachain on Kusama is way cheaper than deploying it on Polkadot. So it's cheaper than Polkadot, but it provides real economic values. It's probably more like the more experimental net, which is more accessible for small projects, has lower fees, but is also less battle tested. It's like the battle testing ground for real world projects.
Okay, so I think that sums it up. So anything else you would like to add, since we have concluded?
No, for now it's good. Like everyone is welcome to reach out to me later on Element or Twitter or wherever you find me to ask more questions regarding Ink smart contract development. Thanks for attendance.
Okay, so this sums it all up, and it was indeed a very interesting session. It was very interactive. We saw there's a lot of valuable takeaways for our attendees today. Thank you all for joining this workshop. Thank you for the Thank you for joining this workshop. Thank you, Mr. Achim. Thank you to the Parity team. This would not have been possible without. And IBC Media, of course. So before signing off, just a quick word for IBC Media. It's the biggest blockchain ecosystem initiative from India. We have Polkadot as our headline sponsor. So we do have major events coming up in the coming days, and with a big agenda. So we have hackathons, we have startup pitch competitions, we have DeFi competitions, and we have government-led conferences. And we have lined up 4 hackathons leading up to the main conference, which is in January. Registrations for Hack 1 are going so strong, and we have been receiving a good response for it. So it would be great if you can hop on and register for the hackathons for us, and we promise an exciting environment and top-line mentors and the judging panel. I will be sharing the link for the hackathon sign-up in the chat box below. And do keep following us on our social media at IBC Media and our website, ibc.media, for regular updates. So that's all from my side. Thank you.